So in this video, we're going to take a look at the separate breadboard power supply that we have here in picture. Okay, so yours might look the exact same as are pretty similar to this. And basically it's a really nice USB that we can plug in to get an additional power supply onto the board for pretty much the examples we're going to use is some motor control where we need a higher voltage supply than what the embed can give out to us. Okay, so it fits nicely on the breadboard. The first thing to note is that you probably want to set it up so that your USB is, facing out the way so that you can connect it in nicely rather than having to connect it in on this side of the breadboard. Now, when you want to try and match that up with your embed, you may have to basically turn the embed around, okay, so that your USB is on this side as well so that you can connect in and out easy enough. So you may actually have to turn the embed around if you've had it in a different configuration. Just be careful when you're taking these legs out, and the same with the power supply, just be careful to make sure you don't break any legs, break any pins while you're doing it. Okay, so that's the way I recommend to have it up so that the USBs are easily accessed from the outside. Now, if we can zoom in a little bit, and I'll try my best to keep this as good as possible. Another thing what you're looking for is on the setup here, okay, this is where you're going to get an output. You can see plus and minus there, and that's going to give you an output along your power rails here. It is nice, you don't have to keep it this way, but it is nice to keep the plus lined up with the red and the minus lined up with the blue, and the same on the other side. So again, that'll help you orientate it right. Now, the main thing is what voltage supplies can we get out? And you can see we can get 3 volts. We can get 3.3 volts out here along these power rails. We can get no voltage, so we can turn it off, or we can get 5 volts. And how you change that is in here, there's a little yellow clip that comes off, and depending on if you put it on the far side, you will get 3.3 volts. If you put it on the other side, you will get it to go to 5 volts. And if you connect it in along the center, it will go to 0 volts. So hopefully you can see there, just from that side, that they go in groups of 2. And depending if you do the far 2, it would be 3.3 volts. The inside 2, it will be 5 volts. And then if you put it in the center, it'll be off. Excuse me. So over on the far side, we can have 2 separate voltages. You can see over here, I've got 5 volts set up. So it'll be 5 volts and 0 coming out here. And then down here, I just have it off. But what you might want to do is have 5 volts and 3.3. So I'm just going to change that over. And you'll see there, like, that's no good. I've put it over one too many. It's hard there just with the camera. So now we're set up for 3.3 volts and 0 coming out here. And these will be grounded together, okay? This breadboard does connect across to here. So the ground supplies will be connected across. So you won't need to pull a ground supply in here. So that's what's going to give you out. Now, just talking about the ground supply, you will want to common your grounds. So you'll need to take, you'll see it down here, you'll need to take one lead that we normally do into our embed, and then what we're doing is we're grounding that into here, and likewise it's coming over to the other side and giving us ground supply across. So keep that in mind also when using these power supplies. Now, just to test out a few things and to show you the way some of this works, and the reason that we need an additional power supply. You may be familiar, or hopefully at this stage you're familiar with your embed card, and you'll see up at the top right there, we've got 2 voltage out supplies that we can take from the embed. We've got 3.3 volts regulated, and then we have 5 volts out coming from when the USB is connected in. Now, I've got a multimeter here, and you'll actually see, so I've just connected in with the voltage. If you don't know how to use a multimeter, we're not going to spend too much time on discussing that today, but maybe something for you to check out. So we've got ground connected in, and all our grounds are joined together. We have a common ground, and then the other lead, we're just going to take it in here and we're going to connect it into our 2 pins, okay? And you'll see if I connect it into the top pin, I've nearly 3.3 volts, which what matches up with up here, 3.3 volts. But then if I bring it down 1, so again, if I bring this down 1, and I'll try my best to do it with one hand, you'll see, well, I've actually got 4.999. It usually actually, we're looking for 5 volts. It usually comes out at really 4.95 to be honest, but there it is, okay? Now what can happen in some instances for some of the motors that we're using, that 5 volts can be enough, but or that 4.9 or 4.95 can be enough, but most of the time it's not, and we actually need this voltage down here, this regulated voltage, or sorry, this extra power supply voltage. Because like we said, again, sorry for just kind of turning this up and down, it doesn't necessarily say that 5 volts is regulated either. So it can ripple up and down, which maybe won't be stable enough for us to run some of the motors. Now just to verify a couple of things down here, let's just plug this one in and check, have we got 5 volts coming out of this? Sorry for the poor camera work. 4.99, a little bit, normally sitting at 5. Let's try the other side. Remember, we're supposed to have 3.3 down here on this rail. A little bit less. You'll see if I actually turn, then I'm going to turn this supply off. You'll see there it's gone to 0 because I've put the pins off there. If I put it back on, we should get back to 3.3. That's just hooked back up. Okay. So that's when we're using these additional power supplies. Not as clear as I probably would have liked it in this video, but essentially we usually get a more stable or a closer approximation to the 5 volts coming out of this breadboard than what we actually get from the embed. Okay, sometimes it is good enough, we can run some of these motors, stepper motors, servo motors, or things like that from the embed directly. Listen, you can try it out. Not overly clear in this video, I suppose, but it is good to see how do we bring in additional power supplies, how do we set them up. We're going to have more luck using this kind of down the line, so that's what we're going to do. Just to note how you can set up those different supplies, so you can have 3.3 down here and 5 volts up there, and then just that you need to common your ground supplies in with the embeds, or yeah, the embed. So you need to join that in. Now this is joined internally across. I suppose the other thing to note is you don't need to join. Usually we would take, say, the 3.3 or something across there. We don't need to do that because we're getting the 3.3 here and the 5 volts on the other side. If we did take the 3.3 out and try to join it into the 3.3 over here, what would happen is when we turn this off, when we try to isolate the supply, it would still be turned on because it's still getting 3.3 volts. So it's just a common mistake not to fall down from, because it makes sense if you're kind of giving out a voltage from here and powering it in, you're not going to be able to turn it off. Okay, and just what we're sort of seeing at this stage is there will come a time where we're using these additional voltage supplies because we want to have maybe a higher voltage for something like a wee servo motor or a stepper motor or things like that we're going to use, but we still only maybe need a smaller voltage supply for the likes of LEDs and switches and things like that. So there can be circuits where you have different voltage supplies, and that's how we set them up.